The problem statement from GATE Physics 2015 reads as follows. A particle with rest mass m is at rest and decays into two particles of equal rest masses 3 by 10 m, which move along the z-axis. Their velocities are given by. So this is a multiple choice question with only one correct answer. We need to find the correct answer. V1 and V2 are the velocities of the particles, which are the result, the daughter particles, you can say. Before we start solving this problem, let's have a quick recap of the relevant concepts. This is a frame S is given. This frame is at rest. That's why you call it rest frame, or sometimes it's also referred to as the laboratory frame. And in this, we have a particle P, which is moving, let's say, in positive x direction with a speed u. And this observer, this in the rest frame, an observer is measuring this velocity to be u. Now the rest mass of this particle, we am assuming it to be m naught. Then the relativistic mass, which is given by small m, can be written as gamma times m naught, where gamma is the entity that we had seen, that it's 1 over 1 minus square root of 1 minus u square over c square. So that gamma remains the same. Note that since gamma is greater than 1, the relativistic mass slightly increase. Now once we have the mass, we know momentum is mass times velocity. So in this case, relativistic momentum would be relativistic mass versus the velocity, which is the u in this case. And if we replace m as gamma m naught, so relativistic momentum comes out to be gamma m naught u. Similarly, the rest energy, when the particle is not moving, that is, its energy is equal to m naught c square. However, when this same particle P starts to move, the energy it will have, it's called the relativistic kinetic energy, it will have a momentum component as well as the rest mass energy component. So that's it's given by this formula, square root of Pc whole square plus E naught square, and we can also write it as gamma m naught c square, where again gamma is you can see 1 minus u square over c square, and correspondingly the relativistic kinetic energy will be total energy E minus the rest energy E naught. And this is the E equal to mc square, which you have seen, I hope you would have seen, is the famous mass energy equivalence. Right, now that we have had a brief overview of the concepts, we start solving this problem by going through a series of pre-checks. So we check whether all the frames in this problem are inertial or not. So we see that the problem says there is some capital rest mass m, and then it decays into two particles, right? So there must be some observer which is observing all this. So usually that happens to be the frame S, which is we call the rest frame or the lab frame. Since usually this is at rest, so we know all the frames which are at rest are inertial, so S is inertial, and that is the only frame in this problem. There is no moving frame. In some other problems, usually we have some S prime frame, which is the frame of reference of some particle, but this is not the case here. So in this case, this is not applicable. The point B is not applicable in this case. The number of dimensions, the question explicitly talks about only one dimension, which is in this case the z-axis. So this is the one dimension, and we take this to be the z-axis, and I'm assuming this to be the positive z-axis. Right, so this is the picture. So again, I'm drawing this is the positive z-axis. So we know capital M equal to 3m by 10. This is the information that we have. We don't know what are the velocities u1 and u2, and this is the problem. So if you can see, there are two variables that we have, u1 and u2, right? And we need to find an answer. So we need at least two expressions. So first expression will come from conservation of momentum. So we know this is a problem of decay, so the momentum there is no external force, so the momentum must remain conserved before and after, right? And the momentum for a relativistic system is given by this formula, right? So let's just try to so I'm calling it capital P. Note, momentum is a vector quantity. This will be P1 plus P2 vector, right? So capital P would be gamma. So note that this is at rest, so gamma would be 1 for this, so I can write it as 1 times m times 0. It's at rest, so it's 0. P1 would be, so this will be gamma 1 times rest mass is m times u1. I'm calling it z cap. Note this is the positive z direction, plus gamma 2m u2, again positive z cap. So the left LHS is 0, so I can write, if I take m common, so I can take gamma 1 u1 plus gamma 2 u2 should be equal to 0. This is the expression that I find. Now note that the gamma in turn is a function of u, right? It's given by this gamma equal to 1 over 1 minus u square over c square. Now let's just, so there must be a solution to this expression, right? We can try to find we can try to find it out. So what we do is that, so gamma is written as this, so I'll write this here. So this will become u1 divided by square root of 1 minus u1 square over c square equal to minus u2 divided by 1 over minus u2 square over c square. If I square on both sides, right, so I'm writing that here, it will be u1 square over 1 minus u1 square over c square, which will be u2 square over 1 minus u2 square over u, and if we take the invert of this, right, so it will become 1 minus u1 square over c square over u1 square equal to 1 minus u2 square over c square over u2 square, right? So what I'll get is 1 over u1 square minus 1 over c square equal to 1 over u2 square minus 1 over square. That terms get cancelled and I'll get u1 equal to plus minus u2, right? So I notice that u1 is equal to plus minus u2. Okay, so if I place this value over here, right, so gamma is a positive quantity, and if this term has to come to 0, if this expression has to come to 0, so if gamma is positive, then u1 and u2 have to be of the opposite side. Otherwise this will, if let's say both are positive, u1 and u2 both are positive, gamma is positive, this will always be a positive quantity greater than 0. It can never be 0, right? So but from that we have to drop u1 equal to plus u2. So from this expression we have obtained that u1 equal to minus u2. So this is the thing that we had obtained, and also I can just simply say that mod u1 equal to mod u2 equal to u, just for the sake of their magnitude are the same, their direction is the opposite. That's the thing that we have determined over here, right? So we saw that this is actually modulus, so modulus u1 equal to u and modulus u2 equal to u. And now we apply the conservation of energy, and these are the expressions. So I'll write expression capital E equal to E1 plus E2. So capital E would simply be gamma capital M C square equal to gamma 1 small m c square plus gamma 2 small m c square. So gamma is 1 because this mass is at rest, so it will be mc square equal to mc square gamma 1 plus gamma 2. Now we already noticed that gamma 1 was 1 minus mod u1 square u1 square over c square, and this will be equal to 1 minus u square over c square. We noticed that, right? Because u1 magnitude is u, you can see that here, and this will also be equal to gamma 2. So what we'll get here is that c square gets cancelled, so m equal to 2m times gamma 1, right? And this will give me gamma 1 equal to, so the value of small m is known, it's 3m by 10. This was given in the problem itself. So I'll get gamma 1 equal to twice of 3m over 10. So this will come out to be the 10 goes upstairs, so gamma 1 is coming out to be 5 by 3. Now we know gamma 1 equal to 5 by 3, so I'll simply put 5 by 3 equal to 1 over 1 minus u square over c square, right? So if I take a cross multiplication and take the square, it will be 1 minus u square over c square. This will be 9 by 25. So u square by c square will come out to be 25 minus 9 is 16 by 25, and this will give me u equal to, so square root of 16 is 4, so 4 over 5, that's 0.8 c. So the value of u we have obtained is 0.8 c, right? So we obtained u equal to 0.8 c, and we noticed that the magnitude of both u1 and u2 were equal to u, which in this case would be 0.8 c, but we also noticed that u1 was minus u2. This means they were in opposite direction. So we note with the magnitude should be 0.8 c, so this cannot be an answer. This is 0.6 c here. This cannot be an answer, so it's one of these two options. And so if the answer is 0.8 c, yeah, so the velocities are opposite to each other, so option B is the correct answer. The magnitude is 0.8 c and their velocities are in the opposite direction. Thank you for listening.